All right, welcome. This is the review for summative number 8 in the fall of Algebra, fall of 2019 for Algebra 2. And the very first section is a repeated section from 6.8. We're going to be graphing radical functions. This time, I believe we're just focusing on the square roots. We're going to leave the cube roots off of it for this test. So a little reminder about what square root graphs look like. Their general shape has this origination point, and then they kind of bend over to the side like this, where if you look at the table, they have a bunch of errors, and that's because the domain of this function starts at a certain value, and then everything before that value, doesn't exist. So if you go to your table before that value hits, you're going to see a bunch of errors. So first thing I want you to be able to do is, can you graph it? So what I would do is I'd go to y1, and I'd type in, make sure that's a negative symbol, the negative square root of negative 3 times the square root of x, and then make sure the plus 7 is out of the radical. And then what you're going to see on your table, you're going to be able to pull some points for me, okay? So after the errors stop occurring, you're going to see, let's see, 0, 7 will be your first nice ordered pair. And then, let's see, there should be another one at 1, 4. And then, let's see, 4, let's say 2, 8, 6, 4, 1. So plotting all those ordered pairs, oh, that's tiny. Sorry about that. 1, 4. Gosh, I'm not going to be able to graph this very well. And then if you use your calculator for a little assistance, you're going to get this sort of a shape. So there are a couple of transformations we're hoping that you can identify here. The fact that there's a negative in front of it means that you have a reflection. You can just write reflection. It's technically a reflection over the x-axis. The fact that there's a 3 in front of it means you have a vertical stretch of 3. And then this plus 7 off to the side here is a vertical shift of up 7. I ran out of room. So there are 3 transformations on this graph that we'd like you to identify. And all those transformations that you identify, you should see them up here on the picture or in your calculator when you look at it there. They should match. All right, so the domain of your function is measuring from left to right. So our domain starts at x equals 0 and then goes on forever to the right. So we're going to be using a bracket on 0 because it is inclusive, and then off to infinity. Remember, range measures low to high. So this particular function, it doesn't look like it's going very fast, but it is moving downwards forever. So it starts the range at negative infinity, and then it's going to stop up here at 7 with a bracket. I think a few of you need to work on your domain and range a little more carefully. Those can get tricky, but a little more practice, maybe come and see me before school, after school. All right, this is our first attempt at circles, and I have a feeling this is going to be our last attempt at circles because you guys are really good at these when we're practicing them. The formula for the circle looks like this, where you have some built-in negatives for both the x and the y. So it's x minus h quantity squared, and then y minus k quantity squared, and then it equals your radius squared. So there are 2 built-in negatives you got to watch out for this time. So our center for number 3 is located at h comma k. So this particular one is located at positive 9 comma positive 6. So some of you were thinking, oh, opposite signs on both of them this time, and that's a fine way to think about it. Now this number, 81 is equal to r squared. So if you want just r, you're going to have to square root both sides of this. So r equals 9. All right, moving over here, can you create the equation of the circle if I give you the information you need? So the formula is going to start off with x minus something quantity squared and plus y minus something quantity squared equals r squared. So x minus h, this is h right here, get my color straight. So x minus negative 2, this is going to change to a plus 2. And then y minus 5, that would be y minus 5 quantity squared. And then remember, it's r squared, so if you took the r and then you squared it, that would create a 49 back here in the equation. So we will give you those, it's going to look just like this on the test. So we're going to give you kind of the skeleton of it. We do want you to understand how the formula works though, so make sure you study up on that formula a little bit. All right, here's another new section. We're going to be graphing some parabolas in various forms, and only 2 forms on this test. So you're going to be graphing in vertex form, and you're going to be graphing in standard form. So what we want you to remind yourself about is that vertex form is the one that we actually like a lot because you can see the vertex. So it's x minus a times x minus h quantity squared, and then plus k. That's what we're going to be using right down here. And the vertex for that formula is located at our friend h comma k. Now notice there's only one built-in negative in this formula. Don't confuse this with the circles. The axis of symmetry formula is x equals whatever this h value is. So once you can figure out that x coordinate for your vertex, it's a lot of things. It's the center of your parabola, it's the axis of symmetry, it's all sorts of good stuff. So this particular question, quantity x minus 4 to the second power minus 5, your vertex is at -4, comma -5. I wrote really big, sorry about that. Which means my axis of symmetry is also at x equals -4. So that should match. The other thing I want to point out to you guys, this is a line, so make sure that you have x equals in front of that -4. Don't just tell me -4. Here's the reason I want to see that, is because the axis of symmetry is a line that you should be able to use a highlighter and actually graph it on your paper. Oh, that's not straight at all. Maybe it'll fix itself. Pretty good. Okay, so this is the axis of symmetry. We should be seeing everything kind of surrounding that. Now on your table, and this is on your calculator, remember you're going to type your function into y1, this guy right here, exactly how it looks. And we know our vertex is at -4, -5, but if for some reason you weren't sure or you think you maybe made a mistake, you're going to be able to confirm that for me right now. Because if you put your vertex and you kind of center your vision along your vertex in your table, and I'm talking on the calculator, right? So you go to second graph to get your table. You're going to see what we hope are symmetrical points. So above the -4, you'll have -5, and below it you'll have -3. And then I'm going to have to do this mentally because I don't have a calculator pulled up right now. But I can do this. All right, so -4. So this is what it looks like to see symmetry surrounding your vertex. These 2 ordered pairs right here should match. The y value should be the same. So that makes them go just as high or as low as the other point. All right, let's start graphing. We have a point at -5, -4. Oop. And then you have a point at -4, -5. And then a point at -3, -4. So I'm graphing, ooh, that's ugly. I'm graphing a parabola. This was supposed to be really curvy and it's not looking very curvy. I'm graphing a parabola who has a vertex at -4, -5. It's opening upwards because there's no reflection component here. And that's what it should look like. So I'm feeling like we did something right there. Now standard form, nobody likes standard form. It's kind of irritating. Standard form is not very helpful when it comes to finding the vertex. You have to do a little bit of calculation to find the vertex, and it's based in the axis of symmetry formula. So the axis of symmetry, which we know is the x value of the vertex, same number, is found by taking -b and dividing it by 2a. And then once you find the vertex, however you find it, that's going to be the center of your table. So some of you found out that if you did that on the, just looked at the table, it was easy to see the symmetry in most cases. So whatever this number is, it's going to be this number right here, right? And then we're going to get this number by plugging in the x into the formula. And frankly, we're not going to do any of that. We're going to make the calculator do all of it. We're going to look on our table. All right. So calculating -b over 2a, the opposite of b would be +8 over 2 times a would be 2 times 2. So that becomes 8 over 4, better known as x equals 2. So y'all just found a few things for me. You found the line of axis of symmetry is x equals 2. And you also just found out that the vertex starts at x equals 2. And this is where, frankly, you can stop your mental math. So you can go and look at, woohoo, I did not mean to do that. You can go look at your table on your calculator. And if you think your vertex starts at x equals 2, which it does, you should be able to find that. So again, we're typing our formula into our calculator, into y1. We're going to get 3 points with our vertex being in the center of it. All right, here we go. So x equals 2. This one I'll go ahead and show you what I'm talking about with the calculator. What's my formula? 2x squared minus 8x plus 3. Now hopefully you reset your calculator before you started your test so you don't have all this weird stuff going on. That's the best way to start your problem. Or your day, actually, is to do that. I already forgot. I think it was minus 8x plus 3. Well, let's find out. We think our vertex was at x equals 2. And if that's true, I should see symmetry surrounding it. Yep, I do see symmetry. So the vertex is at 2, negative 5. And look at the point above that and below that. We see that symmetry. So 2, negative 5, and then the others are negative 3. All right. So 2, negative 5. And then I think I remember these were both negative 3s. So then we plot. Alrighty, 1, negative 3. You know what I didn't do though? I should have drawn in my axis of symmetry, but that's okay. I'll get this done next. And then 3, negative 3. So we do have kind of a... Ooh, I missed. Okay, we have a skinnier parabola. I do see the axis of symmetry at the line x equals 2. So that's all working out. And then... Ooh, I missed. Okay, pretend that was over. The axis of symmetry totally at 2 is something I also want to see on your paper. Alright, so those two forms, that's what you're responsible for on your test. If for some reason you get in a jam and you're thinking, oh man, I can't remember the negative b over 2a formula, remember we're always looking for symmetry on our table. So you should be fine once you remember that rule. Okay, this is all on your calculator. So you're going to use that little salmon colored reference card. And that's going to help you with some of the keystrokes. And remember, that's actually what I'm testing you guys on. So you can't walk up to me and say, hey, Abruzzo, I don't remember how to get this on my calculator, because that's actually what I'm testing. So you need to be able to do this part yourself. So what we're going to do is we're going to take our function, which will be given to you, and we're going to type it into y1. Okay. So we're going to type that into y1, and we're going to look at the table from our calculator, which remember is second graph. Alright, so I'm going to need to get this typed in. Alright, so we have it typed in, and then we go to second graph. And then I already forgot what I'm supposed to do now. I'm looking for 2 seconds, 3 seconds, and 4 seconds. So there's 2 seconds. So 310, 415, 488. 310, 415, and 488. I'm kind of worried I typed that in wrong. I'm just going to go back and double check. And as long as I can follow your work, if you do what I do sometimes, which is mistype things, which I think I'm okay this time, but I can still follow how you did the next problem, I'll give it to you. You know, I realize sometimes we just mistype. It happens. So I want to know the rate of change between time equals 2 seconds and 4 seconds. So I'm going to box in the data from 2 seconds and 4 seconds. And then the way you find the average rate of change is you take the change in the height. So this is an arrow, right? So the change in the height divided by the change in the time. So for us, that would be, and it doesn't matter what order you subtract them in as long as you stay consistent. So 488 minus 310 over 4 minus 2. So let's see, that's 178 divided by 2. I know I should be able to do this in my head. Is that 89? I think so. I'm nervous now. Okay, 178 divided by 2. Ah! It's that kind of a day. There we go. Alright. So it is 89 feet per second. You don't need to worry about labeling this one. I did put the label for you. And the label actually is kind of a clue. If you forgot how to find this, it says take the number of feet that you're changing and divide it by the number of seconds that you're changing. So that was kind of like a nice you're welcome from your teachers. Okay. So here, we're going to be using our calculator again, and we have a new equation this time. This is a ball that's being thrown. And I want to know the max height on the first question. And then the second question is, when does it hit the ground? So this is a two-parter. I'm going to pause the video and get my function entered. And then part of the struggle is getting the right window. So we're throwing a ball up in the air, and I don't care how strong you are not throwing the ball in the air for 20 seconds. Like, it is not going to stay in the air for that long. So I'm just going to go to 6 seconds and see if that works. And I have an old window of it going 110 feet up in the air from a previous problem. Sometimes that window works, so I'm not going to bother messing with it for now. And you know what, that window does kind of work, but it's like way too high. There's a few things in the Y direction I'd like to change. I want to actually see a little teensy bit below ground, so I'm going to go ahead and say -10 for the start of my range. But 110 was way too big, so I'm just going to go to 50 feet up in the air. That's a little better. Okay, so according to my salmon card, if I'm trying to find the max height, which is this guy right here, they want to know how tall it is and when does it occur. Well, it happens like right after 1 second, so like I'm just estimating like 1.2 seconds. So I'm going to keep that number in mind when I go to do my left bound and right bound. So second trace, and then I'm trying to find a maximum, so choose the maximum. And this is where you either have to type and hop or you have to scroll. So right now your cursor's like way down here. So if you're scrolling, you got to hit the left arrow for a little while until you see him, and then get him so he goes way over here. All right, there we go. So he is before the maximum occurred. So hit enter. If you typed a number, you don't have to hit enter anymore. All right, now get to the right of him, or get after the maximum. And then when it says guess, just hit enter one more time, regardless of which method you're using. And you're going to get an ordered pair. Let's go to the hundredths place. So the max height is 30.56 feet. This is the height. So 30.56 feet. And then at what time did that occur? That is the other part of the ordered pair. So 1.19, I'd round that to. So 1.19 seconds. Now, cracks me up when kids get those backwards, because would you tell me that the ball went 1.19 feet and it took 30 seconds to get there? Like, no, that doesn't make any sense. So think about your answers before you commit to them, okay? Now I want to know when the ball hits the ground. So I'm looking for this moment right here. This is where it hits the ground, and I can tell it's between 2 seconds and 3 seconds. So we're going to go back to the second trace menu, and then according to my salmon card, I'm supposed to choose 0, because hitting the ground is where it has 0 height. So you just have to be before it hit the ground, any place before it hit the ground, which this is fine, so I can just hit enter. And then right bound, they want you to get after it hit the ground. That's why I like to go a little negative with my window, that way I can see it. All right, it's below ground, so enter. And then enter one last time when it says guess. Oh, I'm glad this happened. Anytime this E shows up, this is just scientific notation for 0. This means like -0.00000000009. So there's really jagged pixels on this picture, and it's doing some really awesome math on not a great window with weird pixels. So your calculator doesn't really think it's at 0, but it is at 0. So just know that means 0. The time, however, is 2.57 seconds. So you're gonna want to always think about your answers in terms of real life. You know, if we threw a ball, would it take about 3 seconds for it to hit the ground? I mean, yeah, it depends on how great you threw it. You might want to make some notes to yourself about where we did all these things on the calculator, right? So like on this one, we went to second trace. Oops, that's an E here. And then we went to number 4, the maximum. And then on this one, we went to second trace. Jeez, I can't write. And then we went to number 2, which was the 0 finder. Now the actual steps on your calculator of moving left bound and right bound, that is just something that comes with practice. You just got to get really, really good at that, okay? And no, I cannot help you in the middle of your test. All right, this is another kind of new section. It involved an old topic of factoring. So we are asking that you're just really good at factoring on these. And then once you have your factors, we're going to solve everything. So we're going to take our turn equaling 0 for each of the factors. So this is a basic trinomial. It's going to factor into x and x. And then I need my numbers to, remember, they're going to multiply to -21, and I need my arches to add up to -4. So what if we did a -7 and a +3? You would want to check your arches because you don't want to solve the wrong factors. And then if you took each of your factors and you solved them, you would get x equals 7. And then over here you'd get x equals -3. Please don't just tell me it's the opposite, because it's a little more complicated than just simply it's the opposite. I'll show you what I mean in this next couple examples. Alright, this one takes a little more energy for you to factor it. I want my first numbers to multiply to 2x squared, so we'd have to use a 2x and an x. I need my last numbers to multiply to -5, and then I need my arches to add up to 3. But remember, it's the arches, it's this thing, right? So if I put the 5 at the end, that's not going to work. I'm going to need the 5 to be right here. And if I make it a +5 and a -1, this arch will be -2, and this arch will be +5, and those do add up to +3. So I'm feeling good about my factoring. Now you take each factor, and you set it equal to 0 and you solve it. So this is where it's not so complicated. It's a little more complicated than just take the opposite. So you're going to subtract the 5, and then divide both sides by 2. So there's one answer, -5/2. And then your other answer is really quite easy to solve. Just going to add the 1 over. So this is what I mean by really think about how you're getting the solutions and not just taking the opposites. Now let's be honest, some of you, the reason you're going to falter in this section has nothing to do with your ability to solve the factors. It's going to be with your ability to factor. I don't know why some of you think it's going away. It is not going to go away. This particular question, I hope you start recognizing that this is the difference of two squares pattern. This is actually a really awesome problem. You take the square root of each term, so twin factors we're looking for, 10x and 10x gives you 100, 100x squared, and then 49 would be +7 and -7. So if I were to take each of these factors and set them equal to 0, I do get two different answers. So 10x plus 7 equals 0. You would subtract the 7, and then you would divide by 10. Now I'm not showing as much work as I normally do. That might be a little dangerous for some of you though. Maybe you want to show the plus, -7 divide by 10 divide by 10. So down here, when you set this one equal to 0, you get a similar answer, but it's going to have the opposite sign. So you have 10x equals +7, and then when you divide both sides by 10, you get 7/10. So there's your other answer. Alright, so I feel like some of you just straight up need to work on your factoring, and that might just be a case of you never did your homework, you never did your homework, you never did your homework. Oh, still didn't do your homework. You have to do your homework on factoring, even if it, quote, doesn't count for anything. Even if you feel like you're doing extra work now at this point, it's going to pay off in the end, because factoring never goes away in Algebra 2. It keeps coming back again and again. Alright, I want to wish everyone a good luck on this test. I look forward to some good scores. I think there's a lot of sections on here that you guys have been showing a lot of success, okay? So anything you need help with, come in and get some help before school or after school. Or, never mind, I forgot there's a whole other page. Alright, so there's more factoring here. And I'm a little worried about this kind of factoring because I think some of you just keep forgetting this exists. This is called the common factor type of factoring. And they each have a common 2x that you could take out. And if you have a 2x you can take out of here, you think about, okay, well, what am I left with when I divide this and this by 2x? And we're left with an x and then a plus a 4. So this is one of the factors, and so is this. So each one of those gets set equal to 0. So 2x equals 0 would give you x equals 0 as a solution. And then x plus 4 equals 0 would give you x equals -4 as a solution. So watch out for that kind of factoring and that kind of solving. Sometimes kids get confused because it's a little atypical of what we typically see. Thus the word atypical. Alright, this is just more factoring trinomials. It looks really complicated because you're like, oh no, 16 has a bunch of different numbers that can factor together for 16. But with everything at the beginning and end of these questions being perfect squares, I'm kind of leaning towards my twin factors of 4x and 4x. And then same thing with the 9, I'm leaning towards 3s. And then notice if you make both of your signs negative, those would multiply to positive 9, but the arches would add up to negative 12, and negative 12 would add up to negative 24. So this is unusual because when you take your factor, which happens to be the same factor, just shows up twice, and you solve it, you only get one answer. You just happen to get it twice. So that's why you're going to see only one answer blank for x equals, because it's just the same answer that shows up twice. All right, so now I'm super done. All right, good luck, everybody.